Welcome back to my channel. My name is Dr. Arzu Chabra. I have a PhD in organic chemistry. I am an organic chemistry tutor, and I'm also a mindset academic coach for college students. And what that really means is that I help college students who are stressed out, burnt out, or even preparing for MCAT feel a lot more focused, a lot more energetic, and feel a lot more in control of their time and energy and feel really excited in their preparation for MCAT or any other and I help them remove any other problems that they're going through in their college journeys. So before we get started really fast, I just wanted to mention starting the 7th of July, I'm starting a Orgo review program for MCAT. So we'll be going over the high yielding concepts from Orgo covered in MCAT. And then we'll be getting like a ton of practice from Orgo, from Kaplan, and from a few other resources that will be helpful for you to actually be attempting and getting a really good score on MCAT. And this program, it integrates a mindset coaching, which actually really helps you stay focused, stay on track with what you're learning with me for MCAT and otherwise as well. So if you're interested, the link to my email is down below. Let me know if you're interested. I will send you over all the details and let's get started. Today we're going to go over the chapter carboxylic acids. And so these are at the end of the chapter problems for carboxylic acids from MCAT, the series that we're actually working on right now, right? Okay. So again, really fast, all of these problems, all of these questions are PDFs are linked again in the link down below. And if you want to download a PDF of these problems, feel free to, oh, that makes sense. Feel free to actually download these PDFs when you're trying to solve the problems. Do it yourself, come back here, double check the answer or the explanation, and or do it with me as well, whichever one you like. Okay, let's get started. Which of the following molecules could be classified as a soap? So by definition, a soap is a molecule, right? Which is an anion of a long chain carboxylic acid, right? So a long chain anion of carboxylic acid is actually called a soap. So option 3 over here is actually the correct answer. The anion of long chain carboxylic acid could also be D, but it's not long chain. It's not long enough. That's why D is actually not the correct answer. Which of these compounds would be expected to decarboxylate when heated? The correct answer for this problem is actually option D, right? Because if you actually think about it, for the decarboxylation to happen, the negative charge over here would be created. And then when this decarboxylation actually happens, the negative charge can get delocalized over with that carbonyl compound, right? There cannot be decarboxylation. There's not a carboxyl group. And over here too, there are two carbons at that carboxylic group. That's why that's a problem. And the same problem is over here too a little bit, right? There are 3 carbons over here, 1, 2, and 3, and that's why D is actually the correct answer. Okay, oxidation of the following compound is likely to yield a carboxylic acid. So, okay, so you're talking about acetone, will that yield carboxylic acid? So what we do know is that for us to be able to convert this to a carboxylic acid, you would actually need to break this to form this, right? So you'd have to break the carbon-carbon bond, and breaking the carbon-carbon bond is actually really hard. So less likely. Cyclohexanone, again, a ketone. Third option, 2-propanol. 1, 2, 3, 2-propanol. Okay, so can we actually convert this to a carboxylic acid? So we can first convert this to an acetone for sure, right? By oxidation. Carboxylic acid, again, you would have to break the carbon-carbon bond. That's something that's hard to do. Methanol, CH3OH, can be very fast converted to CH3 double bond OH, right? You have to show up even when you're tired. That's the point. I'm really tired today. I'm still showing up for this video. I was also very sick for the last couple of days, because of which I just decided to just like take a pause from recording videos. But when you're tired, when you're sick, even when you show up, even when you give up, or even when you give your 1% to your goal, that compounds and that gives you long-term results. We are always playing the long-term game, right? So even when you cannot perform at 100% capacity, perform at whatever capacity is in you, right? And so if you judge yourself for not giving you 100%, that's where you're actually slowing down. You're actually not allowing yourself to be imperfect, right? And I've learned that like a long time ago, that when I would do things not fully prepared, I wouldn't actually talk down to myself, or that was a time when I know I was truly learning, when I was showing up even with, you know, less gas in my tank. And so I'm a little bit sleepy right now. Am I gonna judge myself for that? Definitely not. Whatever, it's okay. Okay, so 3D. D is the correct answer, right? Carboxylic acids have higher boiling point than corresponding alcohol because, yeah, why is that? Because the molecular weight increases by additional carboxylic group. The pH of the compound in the solution is lower. Acid salts are soluble in water. Hydrogen bonding is much stronger than in alcohol, which actually is true. Because if you think about carboxylic acid, right? There are two ends that can actually do the hydrogen bonding, right? One of the end is the H. So it forms a dimer. They always form dimers because they can form two carboxyl groups. And then that is the second one. Alcohol can only do one hydrogen bonding from the OH, but carboxylic acid can form two hydrogen bondings, right? And so, of course, that's why they have higher boiling points. Okay, next question. Which of the following carboxylic acid will be the most acidic? So this problem induces the concept of induction, right? So when there are more chlorines, more electron withdrawing groups present, they can actually stabilize the negative charge. They can actually stabilize the anion of the compound. And so that is why actually B is the correct answer for that problem, because there are two chlorines present. So more electron withdrawing group effects that will stabilize the conjugate base. And if the conjugate base is stable, then, right, so this has one only. The acid is more acidic acid. Okay. Next problem. Which of the following substituted benzoic acid compound will be the least acidic? So the one which will actually not stabilize the negative charge. So let's think about this NO2. Is that stabilizing your negative charge? It does. It's electron withdrawing. So electron withdrawing groups do stabilize the negative charge. Okay, what about over here? So for this one, it's also electron withdrawing group overall, deactivating. will stabilize the negative charge? The OH group. The OH group is overall ortho pair director, right? Because it's electron donating, and that is why then that would actually not stabilize the conjugate base of that carboxylic acid. That is why it is the least acidic compound. For option D, you have carboxylic acid. So basically it's a neutral. These are electron withdrawing. This is neutral. This is electron donating. So electron donating would actually be the least acidic compound. Predict the final product of the reaction. So we have Jones reagents. These are oxidizing reaction conditions. So if you really think about it, we have CH3, CH2, whole 4, CH2OH, which really means that we have CH3, CH2, whole 4, C1OH. Just this carbon of the carboxylic acid will fully get oxidized, right, to carboxylic acid, and that's why that is the correct answer for that problem. Dicarboxylic acid is actually not right. That's just like for confusion. That's there just to like confuse you. Okay. And this is like half oxidation. This is like one-step oxidation, but that's not going to happen. More than one-step oxidation will actually happen. So that's option B. Carboxylic acids can be reacted in one step to form all of the following compounds except. Carboxylic acids can be reacted in one step to form all of the compounds except acyl halide. So we can go from carboxylic acid to acyl halide. Yes, that is true. So you can convert your OH to Cl, right? The reaction is using SOCl2. You can convert that to an amide. Yes, you can convert that to an amide, right? You would have to use H plus ammonia. Okay, alkenes, can we convert that to an alcohol? Yes, you can use reducing agent, lithium aluminum hydride, convert that to CH3CH2OH, convert that to an alkene. Yes, you can convert that to an, we cannot, sorry, convert carboxylic acid to an alkene. There's not really a reaction for that. So C is actually the correct answer for that problem. Option 9, the reduction of carboxylic acid by lithium aluminum hydride will yield what product? Alcohol, right? We know that. Okay. Which of the following cannot be used to convert butanoic acid to butanoyl chloride? Of course, CCl4. CCl4 is a solvent. It's never actually used in chemistry as a reagent, right? PCl3 can do that. PCl5 can convert your butanoic acid to butanoyl chloride. So it also effectively it converts your OH to a Cl. But CCl4 actually doesn't do that. It's just like there for a confusion. Which of the following reagent will reduce butanoic acid to butanol? Okay. And here is an important question. Butanoic acid, 1, 2, 3, 1, 2, 3, 4, butanoic acid, 2A butanol, 1, 2, 3, 1, 2, 3, 4, CH2OH, right? So now, which of the following reagents will reduce butanoic acid to butanol? We know we have a very strong acid, and when we go from very strong acid to alcohol, right, what we really need is strong reducing agent like lithium aluminum hydride. Okay, we know sodium borohydride is not actually strong enough for that. If we were going to go from a ketone or an aldehyde, then we could have converted that to form the alcohol. But if you actually use lithium aluminum hydride, that is actually not so lithium aluminum hydride is actually pretty strong, so it can do that, but not sodium borohydride. However, option A and B are actually the same options, right? So here's like a little bit tricky, right? The answer, I know the answer key says option A, but that's not the correct answer. Option B is like some of those questions not made by chemists. Option B is actually the correct answer, and why? Because when the reduction happens, right? 1, 2, 3, 1, 2, 3, 4. So it actually it forms CH2O minus. That is the last step of the reaction when they actually form lithium aluminum hydride. Okay, and then in the next step, or maybe there's a revised version of the textbook, which I don't have, and they might have the correct answer on that one. So I'm not really sure. But whatever the version I have for MCAT, I think it's 2022, they said A as the correct answer, but it's not. Because then you need water to make the product and alcohol to make a neutral product. So actually, you need the water, or they sometimes also add methanol in the workup step to get that extra hydrogen, H+, because lithium aluminum hydride is a source of H-, right? It contains a lot of H-. However, in this final product, we need the H+ to make this molecule neutral, and water provides that H+, and that's why we need a source of H+ to go from here to here. So H2O, the answer with H2O is actually the correct answer for this problem. In the presence of an acid catalyst, the major product of ethanoic acid and ethanol, okay, that's an esterification reaction. So the correct answer, ethanoic acid and ethanol, diethyl ether. Is that correct? Probably not. Ethyl acetate would be the correct answer. Ethyl acetate, ethanoic acid and ethanol, that is the correct answer for that problem. Oh, not bad. Okay, so these were the 12 questions from the chapter of carboxylic acids. Tomorrow, or whenever I feel better, I will be adding the problems, or I'll solve carboxylic acid derivatives. I think they're at the halfway point. We have gone over like 7 chapters, and we have like 7 more to go over. And yeah, I will post that very soon. Until then, keep learning, keep growing. And if you have any questions, please feel free to leave that in the comments, and we'll see you next time. Bye now.